Hi, mentors. Let's talk about two approaches to Frieze patterns. Both are valid. And this applies both to meeting 3 and meeting 4 when you're discussing the patterns. Remember first that it's not something memoristic necessarily. You don't have to just teach from memory. These are the Frieze types, but rather you want to be logical and relate them all and be balanced between just discovery and telling them all. So you have to be logical. You want to scaffold, give like a step by step and relations so that it all makes sense. That it's not just a list unrelated types of patterns, but finding connections between all these types. And how do we do that? There's essentially two types or two approaches that you could mix during the meeting according to your students, and you'll see which work best or not. But we really recommend you to try them both. In coaching, we'll also be checking on those. So the first is external, just like a recipe, like a cake that's already done, and you're just tasting the cake. You are analyzing the flavors, how's it feel, the properties. So you're just a very accomplished chef or whatever, and you really want just to taste the cake and all the properties. You don't want to talk about the ingredients necessarily, just all the properties that bring you. So it's just checking the symmetries of the Frieze patterns. And in this analogy, the second approach would be internal instead of external. So what's the story? How was this cake built? So you have the cake, but you don't really just look at the cake as finished, but you kind of go back in time and what are the generators? What are the ingredients? What is it made of? So if somebody made this strip, infinite strip, how was it made? What was the minimal information, the smallest information that was needed to build the whole infinite object? And also, how was this created, right? Which reflections or rotations, right? So which transformations we needed to apply exactly to get the whole strip. Okay, so let's try to bring this into a more concrete story here. Let's take a look at this Frieze pattern, for example. You could just think about finding lines of symmetry or rotations. That could be one approach, and that's totally valid. So you could check, for example, here that there's a horizontal line, right, of rotation. Let's maybe draw it. Right, you can check that. You can also check that rotation doesn't really work. Horizontal reflection doesn't really work as well, because these kind of C features will just, will just flip in the other direction. So doesn't really matter. And then you discover the symmetries and you can classify and make sense of the type. So that'd be the first approach, just looking for the symmetries externally without breaking the strip. Let's check on internal. What's the story? So you know that a Frieze pattern, just by definition, is repeating something infinitely many times from left to right, right, in all directions. So you could see, for example, you could try to say, okay, this is the tile, right? Let's put it here in this color. This is something that would generate this tile. That's right, because if you copy it over here, and of course here it would just continue. That's valid. But then you tell the story, and is this really the minimal information to make this cake, to make this Frieze pattern? And of course not. You could shrink it a little bit. Okay, so that's better. And of course you replicate this. And that could be the end of the story. Or you could even say, is there something smaller is in this DNA, right? These ingredients, I'm just looking for the most basic thing. What's the smallest thing that you could use to get the whole cake, the whole. And what happens is that if you shrink here, you make this part here. Of course, you could make it a little smaller, but doesn't matter here. And you see, this I see it all the time, all around in the pattern. I see this rabbit here, 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 And I also see copies here. It's just not just translated. So you finally have the initial, the basic ingredients here, the smallest you need. And then you have to tell the story, what happened with this rabbit. So you would say something like, okay, this rabbit was, maybe you try, let's say if rotation works or not. Let's see, take a look. Yep. Actually, no. So it's not rotated. So you then try maybe mirror. So let's do it. So you start with this basic rabbit, then you did a mirror. Yep, that works. So you have this small, then you mirrored it, right? With respect to the horizontal line. And then these two, you just started translating to the right. So you get the story of your tile, and you also get the symmetries, right? Of course, you have translation symmetry, but you also have this horizontal symmetry. Let's take a look at this one here. Same story. Externally, you could check for the lines of symmetry or rotations that you could have. Internally, looking at the smallest generator, what's the story of this pattern? How was it created? Okay, you could say it's created by just replicating these two shapes all over. You could get smaller also. And you want this flexibility. You want in your discussions to be flexible and have different valid ways of seeing things and connect them. Okay, you could do this, but then you could ask, I see many repetitions over here anyways, so can I really shrink it? Okay, here. Yes, I think if you vertically reflect this, you'll get this. But can I even do better? So let's try to even do a little better here. Will it work? Okay. Yeah, and then you check if this works or not, and what would be the story. So for example, you could say that the story was flipping along the horizontal line, like this. Does it work? Yeah, I think it works. And then the other story was either rotating these two rectangles or mirroring. So both stories are correct in this case. So you started with 1/4 of this, then you kind of duplicated here. So we had half of this, and then you also duplicated here with a rotation, and then you found your tile to copy over by translations to the left and to the right. Of course, this is infinite. It also goes that way, of course, to the left to get the whole tile. Here's the same. So you can also pause the video and try, but this would be, you would start maybe with this one. Make sure that, right, this kind of U here generates this. But of course, you know that there's kind of repeated information in this tile, so you can shrink it for a more fundamental shape, right? And then you could ask yourself, what's the story, right? How do I get now these 4 rabbits out of this? So here, what you would do is you could maybe rotate. Let's see if you rotate. Yep, that works. And so on. You could maybe rotate again. Let's try. Nope, it doesn't work. So what we could do is then vertical reflection. So as you tell the story, you naturally discover the symmetries. So of course, this method, it's also checking for symmetries. It's just in another way. It's just a different way. Okay, so that works. Same for this one, you would do it, and so on. So I hope this video helps you practice with your commentors and also during coaching all the discussions that you could have both with the whole cake, just finding the lines of symmetry, the centers of rotation, and just checking it without breaking into mini parts. So that's a valid approach. That's kind of mathematically the purest in a way, without getting dirty, just eating the cake. Or go internal, like an architect or an engineer, and just try to look what are the basic parts. Okay, so how was this cake made, right? Like a reverse engineering. It's of course it's a Frieze pattern, so it has a lot of repetition. So you know there's always translating to the left and to the right, but you want to see if there's more, right? Once you find the tile, you want to keep breaking it and find any symmetries. Okay, so see you in another video. Thank you. Goodbye.